So this ratio of circumference to diameter seems to be constantly equal. And so that's why we call the quotient a constant of proportion. C over D equals the constant pi, and that's approximately equal to 3.14. But pi is not the only constant of proportion. Let's take a look at what Lavoisier found when he was studying how water broke down into oxygen and hydrogen. He saw that the water he put through the hot iron pipe converted into some oxygen that added to the weight of the pipe and some hydrogen as a gas. Let's look at the measurements that he made of these different masses: the water lost, the pipe gained, and the flammable gas that was released. In one test, he might have found that 18 grams of water was lost, the pipe gained 16, and there were 2 grams of hydrogen. In another, he might have noticed that 54 grams of water was lost, 48 grams of mass was gained by the pipe, and 6 grams of hydrogen were collected. Finally, 90 grams of water was lost in one case, with 80 grams of oxygen being gained in the pipe and 10 grams of hydrogen being collected. In all of these cases, you'll see that conservation of mass holds. The mass of the water lost was equal to the sum of the mass gained by the pipe and the gas. But something else is interesting here, and that's the ratio of oxygen to hydrogen. Let's calculate those ratios. So the ratio of 16 grams of oxygen per 2 grams of hydrogen gives 8. And 48 grams of oxygen per 6 grams of hydrogen also gives 8. 80 grams of oxygen per 10 grams of hydrogen, again 8. So Lavoisier noticed that when he divided the mass of water that became oxygen in rust by the mass of water that became hydrogen as a gas, the result was a constant. So he concluded that in water, the ratio of oxygen to hydrogen is fixed. It is a constant of proportion.